Okay, so chemistry at your fingertips is back with its next video, chemical kinetics, the last minute revision. Okay, so I guess most of you by now might have already prepared a lot about this topic. So this topic is pretty much important. And if you could see, the level of numericals basically is from easy to moderately difficult, right? So you could have simple substitution numerical, or you could have something like indirect numerical, wherein you are supposed to find out even the data which is needed for the formulae. You could have certain graphical representations or some sort of statistical data, I would say, or some sort of data, experimental data has been given, and you're supposed to find out the order and the rate, right? So these are the model questions. Other than that, the elementary definitions of these elementary definitions of order, molecularity, first order reactions, second order reactions, the expressions, the rate law, the rate equations. These are the basic things that are asked generally from this particular topic. Okay, so let's one by one get into the details. Okay, so okay, let's start with the formula checklist, which is in front of the screen. For a general reaction, you have n moles of A plus m moles of B. So you already remember the concentration of the reactant decreases and the product increases. So this is given by the negative sign and the positive sign in the reactant and the product side respectively, right? And if you remember, now the stoichiometric coefficients have to be divided. The elementary reactions, the reactions that occur in small steps. So the rate is given by k into a raised to m and b raised to n, right? This is pretty much simple. And for a general reaction, again it's given like this, right? Order of the reaction with respect to a is m for this reaction, and the order of the reaction with respect to b is n. Overall order given as n plus n, right? And most important, I have seen many students getting messed up in this particular part when they are supposed to write the unit of rate constant. There is very simple formula, mole raised to 1 minus n. So if it's not clear, I'll just write it. Mole raised to 1 minus n, liter raised to n minus 1, and time inverse, right? So this, I would recommend that you do this by heart. Okay, especially I've seen that many students lose marks when it comes to writing units. The units of the things which are pretty much what do you say, evident in each and every calculation, like units of concentration, mass, volume, they're easily understood. But when it comes to writing the unit of rate constant or decay constant in certain radioactivity problems, students normally mess up writing the units and end up losing marks. So make sure that you don't commit this mistake. Every single numerical should have the given data, formula, the relevant substitution, the stepwise calculation, as well as the units which are written in a proper way. Okay, so this is a very important aspect, and you are supposed to memorize the unit of rate constant, mole raised to 1 minus n, liter raised to n minus 1, and time inverse. Okay, now let's move ahead. Okay, so for a zero order reaction, the rate expression is already given in front of you. Negative dA by dt, which is k into the concentration of A, right? So basically the constant K value has already been given, A0 minus A upon K. This is initial, this is final, and T half is A0 by 2K. You already know what is T half, time taken for reduction to 50%, right? For the first order reaction, it is 0.693 upon K. For a second order reaction, it's already given to you in front of you. For an nth order reaction, the T half is directly proportional to 1 upon A0 raised to n minus 1. This is very important for the calculations. Basically, you could see that you could use this particular formula for calculation in like MCQs, which are normally asked in relevant board exams. But make sure that at least you can cross verify your answers in theory with these type of shortcuts, right? And the next part is the Arrhenius equation, k equal to a e raised to a minus e upon rt. So this is the log expression which is given in front of you. It would be better if you memorize the value for 2.303 into r. Now r has different units. When to use 8.314, 4.184, 0.082, This you are supposed to know, right? The Arrhenius constant, activation energy calculations. So most important thing is the numerical, which is based on this particular aspect, that has to be memorized completely and properly. Okay, so just note down these set of formula so that this would be like an instant notes for you. Okay, especially calculation of T half. Okay, calculation of T half should be done properly using steps, and again units are a must. Okay, so units, please do not forget to write the units. Okay. Okay, now in this particular topic, what are you going to focus on? So basic definition, what do you mean by order? What do you mean by molecularity, right? What are elementary reactions? What are general reactions? What is rate law? That is decrease in concentration of reactant and increase in concentration of product. What is the integrated rate law? What is the like differential rate law? And the numericals, as I said, the range is from easy to moderate. The numericals are basically from the T half, right? Half-life, calculation of K, and it could be something like an experimental data wherein they are supposed to calculate, they are going to ask you to calculate the order, right? So the ones which are given at the end of the textbook, wherein you have two different rates given and two different values given, divide one by the other. So normally I'll just tell you what exactly it is. We assume the rate is equal to, rate is directly proportional to, let's say if you have a reaction, so A raised to X and then B raised to Y, right? And then you calculate the value for X and Y using the entire tabulated experimental data, right? So these are the pretty much common questions that are generally asked. Okay, of course there could be questions related to Arrhenius equation, K equal to A e raised to minus E upon RT, using the log values at different temperature. Just make sure that you don't do any calculation mistakes. Again, most important thing, the conversions, joule to kilojoule, kilojoule to joule, right? So these are the things that you should take a lot of care about. Now the rate equation and the rate law I've already told you. You are supposed to memorize this. The collision theory, successful, unsuccessful collision theory. What exactly is the graphical representation for a zero order, first order? This is something which you could do it in addition. And again, my important advice to all of you, solve all the end of the textbook questions, especially the numericals, right? The end of the textbook questions would be having theory as well as numericals. You could do the theory orally, but make sure that every single question you are going through, if you are not able to do everything, at least you should know what are the questions wherein you literally fumble, or you could say what are the questions wherein you have less level of comfort. Okay, so these are the very important thing that you are supposed to do it. Now again, this is a chapter wherein the level of questions are easy to moderate level, but yes, you can be asked a difficult type as well, depends, right? So just make sure that you are reading the entire textbook as well. I know this is not the right time to say that, and it would not be better if you start doing it right now, but at least you don't miss any important thing that are very much needed for your exams. Okay, so I wish you good luck and do well. Thank you.